As soon as the Earth is cut in half, almost all living creatures will come to an end. An apocalypse will begin, which has not been shown in movies. The atmosphere is damaged, the magnetic field will change, and the planet's landscape completely alters. But the planet will be completely renewed, and life, like a phoenix, will be reborn from the ashes. A super powerful laser would be needed to separate the planet. Such a laser has to receive energy directly from the sun. The weapon goes into space on a rocket, thousands of miles above our world. Then, once the laser arrives at its destination, it opens wide to expose plates of solar panels. The laser absorbs and concentrates the sun's rays. Then a powerful energy beam with the diameter of several cities shoots into the middle of the planet. Oceans through which the beam passes boil and evaporate from the high temperature. These vapors turn into a vast thundercloud in the sky. A strong wind drives these clouds over the continents. Heavy rain falls, which floods not only cities, but entire countries. As the tectonic plates shift, tsunamis are created. Huge waves crash onto the shore. The Earth is split in two. And this is just the beginning. The structure of the Earth, or rather, each half of it, is changing. Strong earthquakes occur all over the world. The worst disasters happen near the fault line. Billions of tons of ground are smashed. Massive landslides drag entire cities below. Chunks of land, thousands of miles in size, shoot away from our planet. All living creatures on these pieces of land fly into outer space. Other broken pieces of the planet land on the half that is closest to them. Imagine a huge rock the size of a whole city falling from the sky, and there will be hundreds or thousands of such stones. Those who live far from the cut site have a chance to survive. But even there, earthquakes will destroy houses. The moon will also start to throw off pieces from itself. These pieces, like a meteor shower, will fall onto the Earth halves and create massive explosions. These explosions will create fires. The skies will be covered with ash, and until it settles, we won't be able to see the sun. Both parts of the planet are drifting away from each other. The red-hot heart of our Earth is right in the center between the two. This is the Earth's core, consisting of molten metals. Each half of the core exudes energy comparable to a star. Between the two parts of the planet, a layer of such hot space is created that nothing can survive there. Any item that falls into this space immediately turns into ashes. The mass of the core is much larger than the ground mass, so there's a higher level of gravity. The core sucks in everything that comes close. You can't travel from one part of the Earth to the other. The core's gravity attracts any shuttle. Each half of the Earth now lives on its own. Typically, the core inside our planet rotates and creates the Earth's magnetic field. This field is a shield that protects us from the sun and space. If the shield is damaged, solar and cosmic radiation passes through the atmosphere. Because the core is divided into two parts, the Earth's magnetic field becomes unstable. Power outages begin in both parts of the planet. Microwaves, TVs, kettles, traffic lights, computers, everything is broken. The screen of your laptop or phone starts turning on and off. The video may freeze and the battery runs out and charges in 1 second. Satellites stop working, which means there will be no more GPS. High-frequency radio waves used for communication stop working, which means you can't make calls and send texts. In fact, all power plants may sink underground or be flooded because of the earthquakes, so there might not be electricity at all. Some people are sensitive to solar storms and experience severe headaches. When the magnetic field is damaged, the surviving people and animals will suffer from severe migraines. Scientists will have to invent special helmets to protect people from the sun. For full protection, people will have to live in underground cities. Compass needles no longer point north. They just spin in different directions. The birds go mad. They don't know where to fly to wait out the winter, because the south no longer exists for them. All animals stop migrating. In the sky, planes can't navigate. Plants and flowers can't grow naturally thanks to the increased radiation from the sun. Livestock are poorly fed. The quality of products deteriorates. There's famine. The main goal for people on each half of the planet is survival. In some places, closer to the fault, the Earth's atmosphere is completely damaged. The conditions there will be similar to those in space. There is no air or heat. Only in a spacesuit can you stay in this territory. Unfortunately, you won't be able to jump and fly because gravity still works. Besides, it's gravity that becomes the salvation of our planet. Both parts of the Earth won't fly away from each other because of the force of gravity. Instead, they will rotate and start to attract each other. In 100,000 years, both parts of the planet will reconnect once more, and the Earth will be completely renewed. Since the core is molten metal, it will return to a single heart, but it will take much longer to connect the solid rock of the halves. A scar forms along the entire fault. The scar will be overgrown with forests and flooded with oceans, but there will be strong earthquakes in some places near this scar. By this time, all living things have probably disappeared. On our planet, conditions are about the same as 4.5 billion years ago. Seas and oceans boil, lightning strikes everywhere, tectonic plates change their shape, and lava flows from volcanoes in a rapid stream. The Earth looks like a vast boiling pot, inside which life is gradually created. Because the Earth has decreased in size and the core hasn't changed much, the gravity will be different. On land, it will be more difficult for an ordinary person to walk. They will weigh much more. In such conditions, new, previously unknown life will be created. Today, the world's atmosphere and oceans are polluted, the population is increasing, and glaciers are melting. In the future, things could be much worse for our planet. In 1,000 years, when humanity has mastered space travel, we may decide to change our residence. We'll start looking for other Earth-like planets, and maybe we'll find something. However, nothing compares to our first home, and humanity decides to cure it. Perhaps we'll come up with the idea to divide the planet in half and live on one side. And after 100,000 years, we can come back to a new healthy home. What if you divide other planets? Since they don't have a magnetic field, they won't be as affected. For example, Venus and Mars have no seas, oceans, or lakes. Some scientists think they're entirely dried up because the magnetic field has disappeared there. This led to the complete destruction of the atmospheres of these planets. The solar wind blew across their surface with such force that it dried up all the liquid. The Earth's atmosphere reflects this wind, so thankfully, we're safe. There would be no significant cataclysms on other planets, except for earthquakes. Like Earth, the two parts of each world would simply rotate until they reconnect once more. It's becoming colder by the minute. The temperature drops below zero very quickly. And although there's no snow, the cold is becoming unbearable. Hoarfrost appears on the ground, the grass, and the trees, and ice forms on bodies of water at an incredible rate. Shivering people all over the planet raise their eyes to the sky, and their jaws drop in disbelief. The sun has become twice as small as it used to be. It now looks like a distant speck, and it won't be able to heat the Earth any longer. But the worst thing is, there's a huge blazing rock coming right at the horrified spectators from the sky, and the impact with that thing will undoubtedly do a lot of damage. Okay, let's go back to our objective reality. The Earth is exactly in the sweet spot of our solar system. It's neither too close nor too far from the sun, making the temperature on our planet not just tolerable, but rather pleasant. Scientists often call Venus, the second planet from the sun, our Earth's evil twin, because it's so hot and inhospitable that no life is possible on it. Of course, There are thick clouds in its atmosphere that rain acid, and the greenhouse gases raise the temperature on the surface to unbearable values. But even if Venus didn't have those, nothing would still be able to live there because of the proximity to the sun. If there was any liquid water, it would evaporate too quickly, leaving life no chance to develop. On the other hand, Mars, going next in line after Earth, is a bit too far away from the sun, which makes it cold and lonely. The temperature on its surface is below freezing, and it never warms up enough for water to stay liquid for long. That's not to mention the lack of atmosphere on the red planet, the element that provides the Earth with breathable air. So, if our planet shifted closer to or farther away from the sun, its temperature would either rise or fall respectively. A few hundred miles wouldn't make much difference. The circling of Earth around the sun is uneven anyway, and we constantly get nearer to our star or fly a bit away from it. The distance that would matter is measured in millions of miles. And yeah, just like I showed you at the beginning of this video, we'd see the sun a lot smaller than we do now if we went that far. The temperatures might not fall at the exact moment of the shift, as there would still be some warmth left. But in the following winter, our planet would probably stay cold forever. The oceans would be covered with ice, and the overall sea level would drop. And ultimately, the ice would reflect more of the sun's heat back into the atmosphere and space, not allowing the surface of our planet to get the necessary warmth. And more ice means less water vapor in the atmosphere. Water vapor captures heat too, creating clouds. So the colder it is, the less rain. The cold and the lack of rain would not let any plants survive for long. So the areas of icy and barren landscape would grow fast, leaving only the areas along the banks of rivers intact for a while. After some time, the rivers would stop running too, either frozen or dried out because of losing their sources, lakes and seas, which would, of course, freeze as well. Any life dwelling near them would disappear. Plants first, and with them, everything else, since plants produce both food and breathable air. And with that, the Earth would become a frozen wasteland. As for the giant blazing rock I mentioned, it was an asteroid coming from outer space because of the shift of our planet's orbit. Jupiter, the largest planet in our solar system, acts as a natural shield for us against space rocks. It has a huge mass, and most asteroids flinging from outer space get caught in its gravity and fall on its surface. There's no life possible on Jupiter, and its surface is gaseous, so asteroids tend to disappear in it without a trace. Still, some manage to get past Jupiter, where Mars comes into play. It also contributes to our defense by holding the asteroid belt between itself and Jupiter in place. The two planets' combined mass creates a gravitational field that doesn't allow the asteroids from the belt to fly in random directions, hitting everything in their path. If there was no Mars between us and the belt, we'd be used to meteor showers almost more than actual rains. Say the Earth has replaced Mars in its orbit, and now we're hundreds of millions of miles farther away from the Sun. The mass of the Earth is more or less similar to that of Mars, so the asteroid belt is still in its place. The temperatures will still fall though, and life will soon go extinct. But if Mars stayed where it is, and the Earth just shifted away, it would be a recipe for disaster. There's no chance the planets would orbit the Sun at the same rate because their mass is not equal. At some point, they would collide with each other. Taking their speed into account, they'd both crack and shatter, perhaps creating another asteroid belt in our solar system. It would be no more hopeful for us if the Earth decided to jump closer to the Sun. Apart from the stars seeming more like a giant, pitiless blazing ball in the sky, its heat would melt the glaciers on our planet, making sea levels rise abruptly. The water would flood major parts of the continents, and more surfaces of the planet would be covered with water, which means more heat absorption. That would bring about a further rise in the temperature. Also, those large bodies of water would evaporate like crazy, releasing tons of water vapor and carbon dioxide into the atmosphere. Carbon dioxide is a greenhouse gas that absorbs heat, and so does water vapor. Together, they would trap more and more of the sun's warmth, creating thick, roiling clouds in the sky, almost like on Venus, but without the acid. And that thick blanket of clouds would also contribute to heating the surface of our planet. In the end, the entire Earth would heat up so much that life on its surface would become unbearable for most. Only the sturdiest of creatures would be able to survive temperatures so high, those that dwell in our deserts, for example. Despite the rainfall, which wouldn't cease as in the cold scenario, plants would still have difficulty adapting to the new and hot environments. The ones in the cooler regions of the planet would be the first to wilt and go. But then, plants from the moderate and finally tropical climes would also give up. And, yet again, the Earth would turn into a barren ball of rock, only this time an overheated one rather than frozen. Our planet's distance from the Sun, its tilt, its speed of rotation around its own axis, its orbit around the Sun, and even the presence of the Moon in its skies, all of that is crucial for life on Earth to exist. For instance, if the planet wasn't tilted relative to the Sun, it would be unbearably hot on the equator and impossibly cold at the poles. The seasons would also stop changing, dividing the Earth into strips of endless summer and winter. Our planet is heated up evenly from all sides with the current tilt and rotation, like you would roast a barbecue. It turns to the Sun with one side to warm it up, while the other cools down during the night. Were there no change of night and day, we'd probably only live in some areas of our planet where constant, never-ending twilight would be. Just imagine our life without those beautiful sunrises and sunsets. Maybe we'll just let it stay as it is, okay?
What would the Earth look like if it was born in another solar system? I did a little research for you to find out, and the results were surprisingly wholesome. There are some warm tropics, strong winds, and giant dragonflies. But okay, let me explain from the very beginning. Since 1995, NASA has discovered more than 4,100 planets outside the solar system. Unfortunately, most of them are either flying ice balls like Neptune or gas giants like Jupiter. But there are still as many as 161 planets similar to our Earth. And one of them is very close to us, in the Alpha Centauri constellation. There are 3 stars in this constellation. 2 of them are called Alpha Centauri A and Alpha Centauri B. If you live in the southern hemisphere, you've probably seen them. They're very bright. Because of that, they look like one big star. They rotate around each other very slowly. And there's the 3rd star, chilling around not far from them. It's a teeny tiny red dwarf, Proxima Centauri. It got its name because of its proximity to our Sun. This star is the most interesting one, so let's talk more about it. Proxima Centauri is only 4.5 light-years away from us. Oh, and 1 light-year is about 6 trillion miles. Yep. If we went there, it would have taken just a little over 165,000 years of traveling in a space shuttle. Oh, you think that's a lot? For the universe, it's like checking on your fridge. Proxima Centauri is much lighter and much smaller than the Sun. It's also 2 times colder than the Sun, with a temperature of 3,000 Kelvin. That's why we can't see it without a telescope. On the bright side, though, it will burn for trillions of years, and you don't have to worry that one day it will eat us like our Sun. And yes, our twin planet is located right next to Proxima Centauri. This planet is called Proxima b. Yeah, I know, they got creative with all these names. I hope you won't get confused. It's slightly larger and more massive than the Earth. This planet is located in the habitable zone of Proxima Centauri. It means that there can be water and even some microorganisms there. Yes, it's possible that one day we'll find some life there. But right now, we don't know much about this mysterious planet. It's probably a rocky planet like our Earth and has a similar landscape, but this is just a theory. Who knows what kind of jokes the universe can throw at us? It would be a shame to fly 165,000 years just to stumble upon a giant piece of ice or something. Fortunately, we probably don't have to wait that long. The big brains are now developing a technology that would allow us to move at the speed close to the speed of light. If they succeed, we'll get to Proxima b in just 20 years. But anyway, this video is not just about Proxima b. It's about what would have happened if life had originated not in our solar system, but in Alpha Centauri. What if we were orbiting Proxima Centauri, or the other two stars? So now, let's imagine that the Earth has replaced Proxima b. I'm going to call this new planet New Earth. Guess I'm not very creative at naming either. First of all, the orbit. The new Earth must be about 25 times closer to its star than Proxima b is. Otherwise, it would be unimaginably cold. Let's move the planet a little closer. Excellent. The day still lasts 24 hours, but our orbital period is very high. Proxima b revolves around its star in 11 days. But we'll make it in just 8. Hey, a birthday party every week? Sign me up. Oh, hold on. There's another problem. You see, Proxima Centauri is a flare star. This means that sometimes, just out of nowhere, it throws out some stellar winds. These winds carry around a bunch of ionized particles, which then settle on the planets. Yeah, our Sun also does that, but Proxima Centauri tries to finish us off 2,000 times harder than our Sun, so the radiation levels are off the scale, to say the least. Don't worry, it's fine. All we need are incredibly strong magnetic fields. They will help us create a very thick atmosphere that can protect us from the Proxima Centauri's tantrums. So now it's going to be very warm. Or not. Another problem. Scientists are still not sure how exactly Proxima Centauri's planets rotate around it. What if they turn out to be tidally locked, like our moon? Then one half of the new Earth will be a frying pan, and the other half will be some frosty deserts. Oh, it's fine, we'll just settle down somewhere in the middle. Didn't expect that I would ever say this, but it will definitely be warm at the North Pole. And if we're lucky with the rotation, we'll just get a cozy, warm planet. The average temperature is about 70 degrees Fahrenheit, and there aren't any extreme temperatures. On the new Earth, we have much more water. The weather is generally pretty crazy. Some very strong winds and quite destructive rains that can go on for quite a long time, but you can adapt. Temperature changes are much more noticeable in the mountains. Just like on Earth, the higher you climb, the colder it gets, except it's very cold right here at the top. Because of this, the mountains and hills have jungles below and snow-covered deserts on the tops. But in general, it's almost like the Earth's tropics. The flora is very rich, the trees are very low but lush. The thick atmosphere also makes flying easier, so there are a lot of large flying animals, like dragonflies with a wingspan of 16 feet. Moving on. The sky here is much lighter than that on Earth and very cloudy. Sometimes it may seem completely white. But the starry night is beautiful and bright. There are 4 suns. Our main one is Proxima Centauri. We can also see 2 bright Alpha Centauri stars. And finally, our old sun, which looks like a bright, distant star. I'll allow you to shed a tear for the old Earth. There's a few planets near us, like Proxima Centauri c. The host star is surrounded by 2 belts of cosmic dust, so get ready for some gorgeous, colorful night views. So what we have in the end is a little crazy, but a beautiful green planet. I personally wouldn't mind moving there already. What about you? Write in the comments. Alright, so now we know what would have happened if our Earth had been born near Proxima Centauri. What about the other 2 stars? Unfortunately, we won't be able to rotate near 2 stars at the same time. Scientists suspect that Alpha Centauri A and B have some kind of common planet that jumps from one orbit to another, but it's probably very cold. Let's choose Alpha Centauri A. Just like on the new Earth, here our average temperatures are about 70 degrees Fahrenheit. But now, the temperature variation is quite large. It goes from negative 100 degrees Fahrenheit at the South Pole to 113 degrees Fahrenheit at the equator. We'll be fine close to the north. The day is still 24 hours, and the orbital period is 1 year and 1 month. It's almost the same for the Alpha Centauri B, but the orbital period is about half a year. Other conditions are very similar to those on Earth. Changes in the seasons are almost not noticeable. The temperatures don't change much either. No matter where we settle down, the neighboring star will be clearly visible, but we probably won't see Proxima Centauri. And that's about it. Of course, all this assumes perfect conditions. Just like on Earth, one slightest change, whether it's a thin atmosphere or a bigger distance from the star, and it won't end well. We got really lucky with our Earth. But even so, the chances of finding a habitable planet are very high. Even with the tiniest possibility, there will be about 15 million planets in our universe that we can find life on.